All right, this is part 3 dealing with rotations on the Unit 1 review. So, number 14, it says, for rotations about the origin, every 90 degrees will move a point to a new quadrant, aka quadrant hopping. So we kind of talked about this in class and in the video. We rotate counterclockwise unless otherwise stated by clockwise or with the negative sign in front of the angle. This is a true statement. I do want to go through this quadrant hopping real quick just so everybody's on the same page with that. If you want to skip ahead to question 15, you can. So, quadrant hopping, we talked about how a full circle is 360 degrees, right? So, if we went around in a full circle, that's 360 degrees. So, if we take a coordinate plane, and we started here and went around in a full circle, that'd be 360 degrees. Since there's 4 quadrants, it's quadrant 1, 2, 3, 4. Since there's 4 quadrants, 360 divided by 4 is 90. That means that each quadrant kind of represents a 90 degrees really. So every 90 degree rotation will basically move to a new quadrant. And again, we always do counterclockwise unless we have like a negative 90, which means we're going clockwise 90 degrees. But that's pretty much it for question 14. It's question 15. Question 15 says, if we are rotating 90 or 270 degrees, we need to switch the, quotes, numbers of the coordinate plane of each point. An example, if a point is at P negative 8, 3, and we rotate it 270 degrees, so a lot of these geometry questions or problems in general, it's always a good idea to draw it out because visualizing it is kind of half the battle sometimes. So in this case, a point is at negative 8, 3. So maybe this is at P, this is at negative 8, 3. And if we rotate it 270 degrees, 270 degrees is 3 quadrant hops. So it'll be 1, 2, 3. So that means it's going to end in this quadrant. That's where P prime is going to be. And then whenever we have this 90 or 270 degrees, we have to switch the numbers around. So that's what this problem is saying here. We would switch 8 and 3 around, so it would be in this order. So it would be 3, 8. And then, because this P prime ends in this quadrant right here where my x's are positive and my y's are positive, that means that both of these are positive. Don't want that little dot in there. So that means that this will actually be where the point actually lands. So this is basically how rotations are performed. This is a true statement here. You could read through that problem again if you need to make more sense of it. We're going to do one of these rules now. So question 16 says, given the transformation above, what is the rule for the transformation? So first of all, you should notice that this is not a translation. What about a reflection? So a reflection, it looks like B and B prime, this is a reflected over the x-axis. But like A, if we were to reflect it over the x-axis, it would be down here. For C, it should be like right here. So reflection doesn't make sense either. That means that we either have a rotation or dilation. Dilation makes something bigger or smaller, so that's not a dilation. So that means that this has to be a rotation. So specifically, I'm going to have a little r to represent the rotation. And then we also have kind of like these parentheses, where the first thing is going to be the angle. So how many rotation, or what degree of rotation. So look how B, or we can start with A. A started up here, and then it went 90 degrees, we'll put it on this line. 180 would put it here. 270 would put it here. So that means that it was 270 degree rotation. Or with B, B started here. So 270 would mean 3 quadrant hops. So we got 1, 2, 3. So 270 works for that. And then C starts here. We got 1, 2, 3 quadrant hops, and that's C. So 270 degrees works, and we're doing it about the origin pretty much always. So my rule for this is going to be 270 degrees. If you have questions about this problem, let me know. Question 17 says, after performing the transformation, rotating 180 degrees about the origin, determine the new coordinates of A prime, B prime, C prime. So we talked about how if it's 90 or 270, you have to switch the numbers around and then figure out where they're going to be at or what quadrant they end at, and then determine if they should be negative or positive. For 180, we did this where we showed that there's an example in the lesson for rotations that we went over, that for 180 degree rotation, all you really have to do is just change the signs of every single x and y coordinate. So A starts off at 2, 4. B starts off at negative 4, 2. And C starts off at 0, negative 3. So when we rotate 180, all we have to do is change the sign. So this would be A prime is going to be negative 2, negative 4. And again, this is only for 180 degrees. For 90 or 270, there's a little bit more work to do. So B prime is going to be positive 4, negative 2. And C prime is going to be 0, positive 3. And then we'll just type those answers in real quick. So I got 2, negative 4. And negative 2, negative 4. 4, negative 2. So negative 2, negative 4, 4, negative 2, and 0, 3. All right, question 18. This is the last one for rotation. So again, we talked about 90 or 270 requires a little bit more work. That's what this problem is for. So we're doing a rotation of 90 degrees. So 90 degrees means one quadrant change. It also means that because it's a 90 or 270, we have to switch the numbers. So the way that it works is we can start off with A is at 2, 3. B starts off at negative 2, 1. C starts off at 1, negative 2. And D is at 4, positive 2. Then switch the numbers around. Again, just the numbers, not like the negative signs or anything. So A prime is going to be 3, 2. B prime is going to be 1, 2. C prime is going to be 2, 1. D prime is going to be 2, 4. Then 90 degrees is one quadrant hop. So for A, again, we're going counterclockwise always, unless they had like a negative 90 or something in here. Since it's positive, we're going counterclockwise. That's terrible. All right. Anyways, counterclockwise. So with A, I would go left one quadrant because it's 90 degrees. So if I end up in this quadrant right here, my x's are negative and my y's are positive because this is left and up, negative, positive. So it'll be negative x, positive y, so that one's done. For B, B starts off in this quadrant. A 90 degree hop, we'll put it down in here where they're both negative. So negative 1, negative 2. C, 90 degrees, would put it up to this quadrant. So they're both positive. D would be hopping over to this quadrant. So it's negative x, positive y. So these are our new points. So A is negative 3, 2. And negative 1, negative 2 for B. 2, 1 for C. And negative 2, 4 for D. All right, that's it for rotations. We're going to finish out in the next video.